All right, guys, welcome back to another lesson for Algebra 1. We're going to do lesson 116 today. So after today, we will have 4 more lessons. So including this one would be 5, but after this one would be 4. So yes, we're so close to being done. Praise the Lord Jesus. And so today we're going to do simple and compound interest, but we are bearing gifts this year. And those gifts are formulas. The formulas, yes, you do have to kind of know them, memorize them, but they make it so much easier. And you can also use your calculator, which in a way, do you really have to memorize them? Maybe you can use your calculator, because I will show you maybe where they are. Maybe, if I'm nice like that. And so first we're going to look at the formulas, then we're going to look at how you actually use the formulas, and then we're going to compare simple and compound interest. That's the third example, and then we'll be done. All right, so let's get into it. All right, so we're going to start with simple interest. Pretty easy. My simple interest formula is I equals PRT, okay? So I means the amount of interest. P means the principal. By the way, when I talk about principal, when I'm talking about finances or business, what I'm talking about principal is the beginning amount, the amount you either get loaned, so you get a loan and that's your principal, or you could also sometimes say that the principal of what you put into an account or something like that that is going to give you interest over time. You have to know that. So that's the principal. Then we have the rate. The rate has to be per year for this particular formula, because the time is also per year. So the rate is going to be per year, the time is going to be per year, and you just multiply the principal times the rate times the time, and you would get the amount of interest that you get. All right. So that's pretty much the formula. Let's jump into the first example with this simple formula. All right. Okay, so the first example, it's 4 different examples in the first one. And so I decided to just break down the problems like this so we can actually do the quick succession, bam, 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 finish with this, because it's not that hard. And so I wrote the formula right here. The amount of interest equals the principal times the rate per year times the time. Now the rate obviously is given to us as a percentage, but we always have to turn it into a decimal. And so obviously I'm going to be using the calculator because it's the easiest way to do it. But you need to know how to set it up. So the first thing that we're going to do here in this example, it says you open a bank account with $4,000. It gives you 5% per year. And in 3 years, how much interest would you have earned in that account? So we're going to start with I equals 4,000 times 5% is 0.05 times 3. And then that would give you I. So let's actually do that. 4,000 times 0.05 times 3 would give you $600. So after 3 years, you would earn $600 in 4,000 out of $4,000. That's not a lot, to be honest with you. But, you know, it's decent. In here, they say you open an investment account now with $12,500. It gives you 4%, and it would be for 15 years. All right, so let's actually see how much $12,500 would give you at 4% for 5 years. 4% interest annually or per year. That's what it means. And so interest equals principal times rate times time. So the interest amount would be the same thing as 12,500 times 0.04 times 15. Don't like that 15. There you go. Better 15. And so now we're going to multiply. 12,500 times 0.04 times 15 equals $7,500. A little bit more than half, but it took 15 years to get to a little bit more than half. You see, that's why you have to be very careful about the way that you think interest works. And this is only when you are trying to get money at a certain interest. Let's see what happens when they actually start charging you. All right. Well, this one is charging, and this one is that you gained $738 in 18 months. But that's example D. So let's do example C. So example C says that you took out a loan for $6,000 at 8.5% interest annually. So it's okay, I guess. This is a little bit high. And you paid an overall estimate of $2,040 in interest. So how much time did it take you to pay that much? And so what they're saying is that at the end, you did borrow $6,000, but you end up paying $8,040. Let me just make sure that it's $8,040. So I would just make sure it's 2040. So what you need to do is solve for t in that equation, and it would be I over, well, crazy. I'm going to rewrite the whole thing. I over P times R equals T. So I is 2040 divided by 6,000 divided by 8.5, which is 0.085, equals T, which is the time. So now I do it in my calculator, 2040. Well, actually, yeah, you can do that. 2040 divided by 6,000 times 0.085. It would give you 4 years. It's crazy. In 4 years, you actually paid 1/3, a little bit more than 1/3 of what you borrowed. This is why you have to be really careful about the money that you borrow. And then D says after 18 months, $738 has been earned, right? So in here, we're going to find R. We're going to do the same thing as in here, but instead of the R being here, we're going to switch it with the T. So it's going to be I over, I don't know why I'm doing my eyes so weird. I over PT equals R. The interest was $738 over the principal, which is $8,200. In here, the time, you have to be careful. You have to put 1.5. Why 1.5? Because it has to be in years, not months. 18 months is one year and 6 months. 1 year and 6 months is the same thing as 1.5 years. So it would have to be 1.5. And so that's 8,200 times 1.5. 738 divided by that would give you a rate of 0.06, which is 6%. That makes sense. So that's how you use the formula. Obviously, the calculator will help a lot, but it's pretty easy. It's not something that I think a lot of you would need to know. Like, not that you wouldn't need to know it, but you would need to be very worried about. So let's actually move on to compound interest, and then we can move on into comparing them. Okay, so let me actually explain this next formula, which is compound interest, because it's a little bit different than the previous one. The other one was very simple, was very easy. This one has a little bit different things. Like, for example, the first thing is A. A does not mean the interest. A means the total amount. So the A means amount. And let's say total amount. Total amount of what? Total amount of whatever you put in P. P obviously keeps on being the principal, which is pretty easy. So A is the total amount of the investment or the loan or whatever it is that you're doing, right? So that's a total investment. P is a principal. 1, obviously, it's just a 1. By the way, that's a 1. I'm going to usually never write my 1s like this, but so that people don't get confused in this formula, I'm going to put a 1 plus R over N. R is going to be the rate. Obviously, it's going to be a decimal, but it's rate per year. Right? So it's the rate per year. And then we're going to have N. N is, and T is time, obviously. So this T right here, I know it's a little bit small, is time. Is time still in years? But then we have N. And N means the number of times it's compounded per year. And this is a term that's kind of weird to understand, but if I actually say, okay, so I'm going to do an investment that is going to be a compound interest investment, they will give me a rate per year, but they will say, okay, but that only is semi-annually. Semi-annually means 2 times a year, so every 6 months. Or they can say every, semi-annually could also be the same thing as a semester, but we don't use that word in finance. We don't use semester. That's more academic. We could use quarterly. Quarterly means every 3 months, so it's 4 times a year. Or in a trimester. No, quarterly is every quarter, so it's 3 times a year. My bad. A quarter of a year. It's 4 months, and so it's 3 times, right? Because 4 times 3 is 12. So the quarterly is every 3, or is it months? Yes, because it will be 4 quarters. And every trimester, it's also every 3 months. But it just, they have all these really weird names for it. So you have to kind of know what they're meaning by it. But N just is the number of times that it's compounded per year. And so what happens is that we have to divide the rate of interest per year by that number, and then we're going to multiply that number times the years, and so that would give us the total amount. This time is not only just the interest, but the total amount altogether, so that includes the principal. So in these questions, they're going to change in that we're not going to ask you how much interest did it gain overall, but what is the overall value? How much is it all together? Because we can't separate it any other way. So hopefully you guys kind of understand this, and then we can move on to the example. So let me then move to the example, and then we will see what happens. Because sometimes just talking about it is not the same. Seeing what's happening, it makes it a lot easier. All right, so let's just go into it. Okay, so we have our formula. The total amount equals the principal times 1 plus the rate over the amount of times it's compounded annually, close parentheses, that is raised to the number of times it's compounded annually times the time. So in the first example, they say, okay, you have $5,000. You're going to put it in compound interest of 6% for 10 years, and it is compounded annually. Annually means once a year. You should know that term. Annually means once a year. It's important now that you guys are getting closer and closer to being 18, because as soon as you hit 18, I am 100% sure that the majority of you, if not all of you, will get credit card offers like this. And young people are so naive that they fall into credit card debt like this. How do I know? Because it happened to me. It happened to a lot of my friends too, because we didn't know any better. People didn't really explain to us what would happen. So I want you to understand what would happen if they give you a $5,000 credit card. So the limit is $5,000 at 6%. By the way, 6% is actually a very low rate. They will never give you that. You probably start over 20% APR, meaning annual percent rate. Compounded monthly, I think it is. So it's per month that they will compound the interest up to 20-something% a year. Anyway, let's do this in the calculator. Well, actually, let's set up the equation. So A equals, what in the world? This is a almost brand new marker. I need it. All right. All right. A equals the principal times 1 plus the rate over time. Why did I put rate and time and not n? Because n is going to be 1. Rate divided by 1 is rate. And n times t, 1 times t is t. So the amount, the total amount you would have, or you would owe, let's say that if you owe this much, would be the principal, which is $5,000, 1 plus the rate, which is 0.06, to the 10th power. We're going to literally write that, put that into our calculator, 5,000 plus 1.06 raised to the 10th power. That would give you a total of 8,954 $8,954 with 24 cents. I rounded the cents, obviously, but look at that. That's how they make their money. Because even though they give you $5,000 and they're like, sure, here, have $5,000, you're going to be like, all right, bet. But in 10 years, if you haven't paid your credit card, they already have made more than twice what they let you borrow at first. And trust me, if we move that 6% to say, and I just want to make an experiment so that you understand how credit cards get you. Let's do 18%, which is actually a pretty decent rate. 18% is actually a really good rate for a starting credit card. So if we do that 18% per year, that would be 5,000 times 1.18 to the 10th power. In 10 years, if you haven't paid your principal, you would owe them. Are you ready for this? At 18%, which is not bad. And this is literally how they make their money. $26,169.18 with an 18% APR. That is ridiculous. That's why you need to learn how to control credit cards or anything like this before you get one. And I'm warning you, be very wise about how you spend the money, because it's not your money and they will make you pay every penny back and more, way more. So watch out. Anyway, let's move on to example 2b. Okay, so for example 2b, I left the information here, the top information, because if I change this to 6% as it was originally written, this would be the answer for example A. This is my example at just so you know, just leave it there for those of you who think having a credit card is cool. And then we're going to actually put that, right? Now we do need N, because N right now is quarterly. Quarterly means 4 times a year. So 4 times a year, we're going to divide 6% by 4 times a year. So you would be like, oh, okay, that's pretty nice, because if we divide by 6% by 4, then it's probably going to be less. But you have to guess again, because what happens is that we're also using this here to raise it to that exponent. So look at how it becomes from this. It equals 5,000 times 1 plus 0.06 divided by 4 times 4 times 10. To the 4 times 10. So this becomes 40 right here, and this becomes something else. But, why break our heads when we can use our handy-dandy calculator, and that's what I'm going to do. So we get 5,000 times 1 plus 0.06 divided by 4 to the 40th power. I got a total amount of $9,070.09. Not 9 million, but 9,000. So if you look at this one, this number, and compare it to this one, that's what happens, okay? It's a little bit, it's slightly more, and you guys are going to be like, whoa, but you know, it doesn't really matter as much. It does, because if it wasn't $5,000, but let's say $50,000, it would make a lot more. And so if it's not $50,000, but it's $500,000, they make even more, or you could make even more if you're the one investing at this rates. But I don't know where they could actually give you those rates. Those rates are pretty good. So before we compare compound to simple interest, and by the way, it becomes a lot easier with the formulas. I guarantee you, the formulas are just savers. And by the way, I'm going to show you in the book the next example, because it's just a lot easier for me to show you how they're doing it there. I already showed you how to do both simple and compound on the board. Let's jump into the book. But before I jump into the book, today's lesson. No, today's lesson obviously is 116, but today's bonus. Today's bonus is going to be two. All right, two things for the ones on YouTube and for the ones on Google Classroom, like always. I know some people got excited. Two? No, not two. It's just one. Okay, so the very few of you that watch it. Less than 7 sometimes. So for those of you who want to comment on the YouTube page, you have to put who's your favorite YouTuber. By the way, don't try to be a smart person, a smarty pants here, and be like, Mr. Thelva, I'm not really a YouTuber. I'm a teacher. I had to become a YouTuber out of this unusual time. But I am not a YouTuber, so it has to be a real YouTuber. You have to put it down below. Just put who your favorite YouTuber is, the 5 first people. Now, if you actually were late for that, then you can actually put in the Google Classroom what your favorite candy is. So that's pretty easy. You have to put favorite YouTuber down below, favorite candy in the Google Classroom. All right, let's move on to example number 3. All right, example number 3, it says an account has $1,000 in it and earns 20% simple interest. Make a table to find the total amount in the account after 1, 2, 5, and 10 years. So it's the same thing. You have to use the formula. They give it to you in the top. They put the years 1, 2, 5, 10, and you know PRT equals A. So the principal is $1,000. The rate is always going to be 20%, so 0.2. And then what's going to change is the time, 1, 2, 5, 10. And so they make you do $200, $400, $1,000, $2,000. So in here, the total in the account would be the principal, 2,000 plus 200, 1,200, 1,000 plus 400, 1,400, 1,000 plus 1,000, 2,000, 1,000 plus 2,000, 3,000. And so in here, simple interest will only give you the amount of the interest, but it won't give you a total amount. You have to add it yourself. That's what they're trying to kind of drive the point here, because if you look at the second part of the example, I know I'm moving you, maybe some of you are going to be like, whoa, what's going on? Earthquake? Nah, just me, dog. Okay, so we have an account that has $1,000 and earns 20% interest compounded annually, so N would be 1, because it's once a year. Make a table to find the total amount in the account after 1, 2, 5, and 10 years. So it's a pretty similar example to example 1, 1, 2, 5, 10, and it's annually, so it is no N. The N is gone, but it's still to the 1 year, to the second power, to the 5th power, to the 10th power. And you will get that in here we have the total amount. So the one in top for the simple interest, for the first year is 1,200. Look at that. For the first year in compound, it's also 1,200. What about the second year? For simple is 1,400. For compound is 1,440. That's $40 more. For 5 years is 2,000. For 5 years is 2,488.32. So that's almost $500 more. For this one, it's 3,000. Look at 10 years. It's 6,191.74. Is way more than double. So that's why compound is great interest if you're earning it, but it's terrible if they are charging you it. So here we have use a table in A and B to graph the account earning simple interest, and the table B to graph the account earning the compound interest on the same coordinate plane. And so you have it. Simple interest is the one in the bottom, and the one that starts to go all the way up here is compound. So compound obviously is going to go way faster up than simple, and simple would just be linear, by the way. A line, always linear. And compound would actually be, it's called exponential function. It's going to be an exponential function. It's not a quadratic function. It's just called exponential. All right, that's it for lesson 116. I will see you guys in the 4 next lessons that we have left.